example, let's think about a transform. If I had an alcohol here, starting with an alcohol, and I want to go to an alkene, it's important to consider the functional groups in our starting material and our product to decide how we're going to convert one to the other. Okay, we're back to our original problem. We want to form an alkene. The way we form an alkene is by eliminating to form the double bond. So, our choices are E1, E2. Those are the only elimination mechanisms we know so far. Those are the only ways we know how to make alkenes so far. We'll learn about some others down the road. Okay, and we have an alcohol. So what if we took this and we treated it with H2SO4 heat? We just learned that alcohols can be dehydrated, so certainly this alcohol could be dehydrated. Would that give this product that's shown as the major product? Now let's think about that mechanism. We know this is going to be an E1 mechanism. It's carbocation conditions. And so we're talking about a primary carbocation, highly unstable, but with immediate rearrangement we can get to a secondary carbocation, maybe even a tertiary carbocation. Okay, but most definitely we would rearrange this carbocation. What do you think that major product would look like if we had to predict this? I think we would end up forming the tri-substituted double bond, the internal double bond, as the major product. Okay, and because we don't want that as our target molecule, as the thing we're trying to synthesize, then this would not be a good synthesis. So what's another way that we can put in that double bond? We need to do an E2 elimination to form the double bond at the end here. So why don't we treat this with TB toxide? We talked about TB toxide as our bulky base, throwing a little heat as our bulky base. What would happen if you took an alcohol and you reacted with TB toxide? Would you expect the E2 elimination? What's wrong with trying to do an E2 here? You lose a beta hydrogen and what? A leaving group. We do not have a leaving group here with hydroxide. So this is no reaction because there's no leaving group. So if we wanted to try and do the E2, but that's not going to happen here. So how can we possibly do the E2 elimination? What do we have to do? We have to make the OH a good leaving group, and then we can do the E2. So an ideal way to do that is to convert the alcohol to a tosylate. So we can use some tosyl chloride and pyridine. That keeps the alcohol right where it is, but turns the OH into an OTS, which is now a great leaving group. And now that you have this great leaving group, now you can treat it with TB toxide and heat and do the E2 elimination. Okay, if you don't want to do the tosylate, you can maybe use something like thionyl chloride, SOCl2, or PBr3 to convert it to a bromide or a chloride. Okay, then we have a good leaving group and we can do an E2 elimination. So we want to keep in mind in synthesizing alkenes, we want to think about, we need to know the mechanisms very well for the E1 and the E2 and decide which is appropriate in each condition, in each situation. Okay, next we'll be talking about the reactions that we can do for alkenes once we have a carbon-carbon double bond in our structure. Thanks for visiting Educator.com.